Hi, this is Adam, and today we're going to be talking about the ROT-47 cipher. The last couple of days we've been talking about the ROT-13 cipher, so this is just going to be an iteration upon those two videos. So if you haven't seen those yet, I'd recommend going and watching those, because this is going to be just building off of what we did in those two videos. Now the ROT-47 cipher is just a different version of the Caesar cipher, which we've talked about a little bit, and the Caesar cipher just falls under the umbrella of a substitution cipher. So both the Caesar, the ROT-13, and the ROT-47 ciphers are all just substitution ciphers, and that's what we're going to be creating here today. Now, first thing I got to do is make sure I have a file ready to put these in. I'm going to go into my scripts folder, and inside of that I have a cryptography directory. And inside of this directory, I'm going to create our ROT-47 YouTube.py file, and that's what we are going to be working in today. So now I can open that in VS Code, ROT-47 rt.py. Now you could be hitting tab to autocomplete some of these things, but that is all right. Now, the very first thing we need to do is set up our key. Now, our key is going to look a lot different from the key that we used during the ROT-13 cipher videos, because that key just included the lowercase English alphabet, A, B, C, D through Z, which was 26 characters long. And since it was 26 characters long, the shift of 13 characters that we did in the ROT-13 cipher meant that you could both encode and decode a message using the same algorithm, because you would end up back where you started no matter which direction that you went. And we're going to be doing a similar thing with the ROT-47 cipher, but it's called ROT-47 because now we have a key that is 94 characters long. And just to prove that to you, I'm going to go in here and let's go ahead and call this our, that's not what I wanted. We're going to call this our key. And there's a couple of things we need to do to make this key work. As you can see, I've got these this red squiggly line under here, and everything looks like a string except for this exclamation point, and that's kind of weird, and we don't have any sort of closing exclamation point at the end. The reason for that is that Python thinks that this exclamation point is where I'm trying to start my string, and in actuality, I'm trying to include this quotation mark in my string. So let's do a single quote and another single quote, and then we're going to add this double quote to basically we're just going to concatenate all of these strings together and add a double quote at the end. And really, there's better ways to do this, but this is how I'm going to do it, just so you can kind of see what we're doing and why we have to do it the way that we are doing it. And I need to add a / there. That just accidentally deleted it whenever I copied it into this text file before making the video. It's supposed to go right there. Anyway, the reason we are concatenating this these strings together is because I want to tell Python, hey, I want you to include this double quote as a portion of the string, and that's pretty confusing to Python. So I'm just putting single quotes around this double quote, concatenating it to the / and the exclamation point, and then concatenating both of those with the rest of our string here. But I'm using double quotes on the rest of this string because there's a single quote inside of here. Now this is all just sort of a roundabout way to go about making this string cohesive, but this is what we got. Now, it's always important to start your files off with a little description of what you're doing. So this is a ROT-47 cipher encoder /decoder. It's important to start your files with a comment, just kind of saying, hey, this is what's going on here. That way anybody who comes and looks at your program can understand what they should expect to see and what they should expect the program to do. Now we're going to create a ROT-47 function that we're going to pass a string into. And we need a couple of things inside of this function. We need our words list. Now this is going to be the exact same setup that we did for the ROT-13 cipher. So that's why it's helpful to go and watch those videos if you haven't seen them yet. This is the same setup that we did for those. We needed to create our a list of all of our words in our string that are split at the space. So each word in this words list is just going to be, if our message that we're trying to encode is the quick brown fox jumped over the moon, then each element in our words list will be one of these words. So element 0 will be the, element 1 will be quick, 2 will be brown, 3 will be fox, and so on. And we're splitting it at these spaces here. And then actually, it is June, what's today? June 20th, 2022. I'm including this with like numbers and things because I want to show you that this cipher can handle any type of string that you pass into it, any type of grammatically correct string that you pass into it using any of these symbols. It doesn't have to be grammatically correct, actually. It can be any type of string that you want as long as it's using these symbols. So now let's create our for loop for word in words. Cryptid equals empty brackets. Now cryptid is going to be where we're going to be storing each of our encrypted words or decrypted words. That's why I left it as just cryptid. But as we iterate through each word in our words list, we're going to be encrypting them. So we're going to be encrypting this the here, and then we're going to put that into our cryptid list, and then we're going to append that to our final list later. So that's going to be the basic function that we're going to be using here. So for letter in word, cryptid.append key of key. I need to put an extra parenthesis in here for something I'll talk about in just a second. Key.index of our letter plus 47. We're going to take all of this, we're going to divide it by 94 and take whatever the remainder is. So this line here, what's going on? We're going to take, for each letter in our word, we're going to take the index in our key, which is up here, and then we're going to add 47 to whatever that index is. And whatever we get whenever we take the letter, add 47 to it, we're going to divide that by 94 and take the remainder. Whatever our result is from this equation here, essentially, we're going to take that resulting index of key, and that is our encoded letter. We're going to do that for each letter in the word. We're going to add that word, or we're going to add those letters into our cryptid list, and then we're going to add that word one at a time to our final list here. Now, let's go ahead and just return this, because something strange is going to happen if we don't do something real quick. So let's return cryptid. Oh my gosh. Let's return cryptid, which is this word, and now we're only going to do this on the first iteration. So this for loop here is going to break after the first word. So we're only going to see a result for the. But I just want to show you what happens if we just put cryptid inside of final here. Okay, print ROT-47 of S. Let's go down here. Where are we in this terminal here? Okay, let's go over to our scripts and our cryptography folder. And okay, we got everything there. Python 3, ROT-47, youtube.py. Okay, so it has encrypted the first word. So T goes to money sign, H goes to 9, and E goes to 6. But as you can see, crypted is still just a list, right? We've just put each letter into this empty list. And now we have the split up into each individual letter as an index of this list. So what we need to do is we need to join those all together whenever we add it into our final list so that we can get a proper result. Okay, so from this function here, we want to return space.join final, and this is going to be our entire function. So here is the encoded version of the quick brown fox jumps over the moon. It is June 20th, 2022, exclamation point. And I think there's actually a space on the end here too. No, there's not. And to prove that that is exactly what's going on here, we're going to copy this, throw it in here, and instead of, so now this is our, encrypted message. Now let's go ahead and decrypt it by passing this encrypted message into our function. And there you go. The quick brown fox jumped over the moon. It is June 20th, 2022. So this has been the ROT-47 cipher. There it is. And it's pretty simple, pretty easy. Like I said with the ROT-13 cipher, it is not a truly robust form of encryption. So if you're really trying to keep something secret, a sufficiently knowledgeable adversary would be able to crack this pretty easily. So it's fun if you just want to, hide some letters and you're not worried about keeping something truly secret. But if you were intending to keep something truly secret, you would need a more secure form of encryption than any of these ROT ciphers or the Caesar cipher, any Caesar cipher for that matter. There are some things you can do to improve the security of Caesar ciphers, and we might go over that in a future video, but that is it for today. Thanks for sticking around, and I will see you tomorrow.